Hello everyone, my name is Dr. Arshad and today we will learn the derivative of dual form of support vector machine. Let's start. So the aim is to minimize the parameter weight in base B and to maximize the function with the parameters of W, P and alpha. So the aim is to maximize alpha and minimize the parameter W in B, subject to the conditions when alpha is greater than or equal to 0 for I is equal to 1 to some value n. Where function capital F of W, B and A is equal to 1 by 2 W into W or W square. As we know, the basic equation of support vector machine is 1 by 2 W square. W is the margin of the hyperplane. So when we write this in a dual form, we write the basic equation of support vector machine, which is 1 by 2 W square, and then we add the other equation. For example, here alpha I into y into wx plus b minus 1. So if you want to understand this parameter, this value, this equation, then you need to watch my other video about support vector machine, where I clearly demonstrate this function. This is actually I will elaborate a little bit here. This is actually the equation which show the value which combine two equation, where the parameter above the plane and below the plane is represented by a single equation and multiplied by the subject value, which is alpha is greater than or equal to 0. The subject alpha is greater than or equal to 0. So when we take the derivative with respect to weight W, then we know that half al W square, when we take derivative with respect to W, then it becomes only W. And because here is only W is available with X, so the B equation becomes 0 and 1 equal to 0. So when we get alpha y I and x of I, summation of alpha I y I and xi, and then as we know that it is equal to 0, so then it gives us the W is equal to summation from I is equal to 1 to n, and alpha I yi and xi. So W is equal to summation of ai, yi and xi, where I is from 1 is equal to n. And when we take the derivative of function f with respect to b, then we see that it gives us the first value, half of w square becomes 0, since there is no b in this. And the other function, the term wxi becomes 0, only the value of b, the derivative value b, becomes 1. So we give here we give it gives us a summation of I is equal to 1 to n into alpha I yi. So which shows that summation of alpha I yi is equal to 0. So these are the two basic equations which we got from this, the partial derivatives with respect to W and WV. We call this equation 1, and we call this equation 2. And the main equation equals to A, capital A. Putting value of equations 1 and 2 into equation A. So we know that the W is equal to summation of alpha AI, yi and xi, and the summation of alpha I, yi is equal to 0. So the equation A becomes f of W, comma B and comma I. So the function with parameter W, base B in alpha I. So I will remind again that if you want to know the basic equation of SVM and the other equation which describe the value above the plane and below the plane or the classification, so please watch my other videos of support vector machine where I discuss that in detail. So let's modify the half omega square value into and put the W value in that, which gives us half into 1 by 2 into summation of alpha I, yi and xi. And similarly the value is put for the second W value. And you know that summation of alpha I, yi and xi is equal to W, and summation of alpha I, yi is equal to 0. So summation of I is equal to 1 to n into alpha I, which is the basic equation, and y into wxi plus then alpha is multiplied with b and y is also multiplied with b. So to actually make this calculation easy, we multiply the alpha value and the y value into their corresponding item. So alpha is multiplied with wx plus b and then 1, but y is multiplied with wx value and b value. So we get alpha y, summation of I is equal to 1 to n in of alpha I, yi and b plus alpha is multiplied with 1, so it gives us I is equal to 1 to n of alpha I. So here we can see the second value where the summation I is equal to 1 to n and y of I wx, there is w available, but in another part we know that B is a base value or constant value. So when it is multiplied with alpha I is equal to 1 to n into alpha I y, which is equal to 0. So when a constant value is multiplied with another 0, it becomes 0. So half of summation I is equal to 1 to n alpha I yi and xi into summation of alpha I yi and xi as it is written in the above equation, and we put the value of w in the second term after minus value. So by putting the value of w, which is equal to summation of I is equal to 1 to n into alpha I yi and of course xi. So one term is already cancelled, equals to 0 by multiplying constant with 0. So we are left with three values. Sorry. So if you could see the two term where one is multiplied with 1 by 2 and another is multiplied with 1. So when we subtract 1 by 2, subtract 1 from 1 by 2, it gives us minus 1 by 2. So we can rewrite this as summation of I is equal to 1 to n of alpha I or ai minus 1 by 2. As I said, 1 by 2 is subtracted from 1, so it gives us minus 1 by 2. And then summation I is equal to 1 to n of alpha I, yi and xi. So this is and of course summation of I is equal to 1 to n of alpha I, yi, xi is 2 times due to the 2w. So basically the base equation of support vector machine margin value is again here represented with the summations of the subject or the constraint value. So this is our desired equation for the dual form of support vector machine. Function of w, b and a is equal to summation I is equal to 1 to n of alpha I minus 1 by 2 summation of I is equal to 1 to n alpha I, yi, xi into summation of I is equal to 1 to n alpha I, yi, xi. So this is actually our desired form of dual form of support vector machine in a simple format, in a simple form. Please subscribe this channel for more informative contents and share with your friends. Thank you.